group. And some people have already mentioned the need for climate scientists to improve the usefulness of their information. And this is really an attempt, or a small attempt, to fill some of that gap in trying to improve the visualizations, which is really the bread and butter of climate science in how we communicate it. So graphical visualizations and maps. How do we use those? How are they interpreted? And really, we have a very small evidence base about how that's actually used in practice by users and adaptation decision makers. So what we've done is a survey that a number of you in this room will have completed. I'm very grateful to those who have filled in this survey, and if you haven't, then there's an opportunity to go and provide some more data. But what I'll try and show is a few results. I can't show you all the results, but a few results from the survey. But before I do, I'm going to use this opportunity to gather some more data, because we have an audience in the room who's the appropriate audience. So I'm going to ask you this question, and then I'm going to split the audience in two and try and get some data, and we'll see what happens. So this is the information. You will be shown 30 years of monthly rainfall data, so 1981 to 2010. And then based only on the following graph, you have to answer this following question. So how likely will it be for the rainfall in April 2014, so next April, to be more than 500 millimeters? Okay? So that question will be on the top again, so bear that in mind. But what I want to do now, this might seem slightly odd. I should say before, what I want you to do is when you've answered the question based on the graph, remember the number. So if you think it's exceptionally unlikely, go for number 1. If you think it's virtually certain, go for number 9. And then 50-50 chance, go for number 5. And then 2 is very unlikely, 8, and you get the idea. So it's a scale. So I want you to remember which number you decide, and then I'll collect that afterwards. Okay, so this is where I'm going to then, I think it makes sense to kind of split down the middle here. We've got slightly more on this side afterwards, but we can always normalize. So I think this side of the room will be group 1, and this side of the room will be group 2. So can I ask group 2 to avert your eyes, cover your eyes, close your eyes. Do not have a look at what graph. I can still see some peeking. Okay, so group 1, this is your graph. And so the question is there, how likely will it be for the rainfall in April 2014 to be more than 500 millimeters? So have a look, spend a few seconds looking at it, and then decide on your number. And remember your number, don't say it out loud. What number are you going to go for? Okay. No peeking on the other side. Okay? If you don't want an answer, if you've got a number, okay, everyone's got a number, hopefully. Right. Now, everyone open their eyes again. Wakey, wakey. And now this side, close your eyes, and do not look at the following graph. This is very strange. And now this is the one, so everyone here is closing their eyes, and on this side, this is the graph you're going to be looking at. So it's the same question, how likely will it be for the rainfall in April 2014 to be more than 500 millimeters? So spend a few seconds looking at the graph, and then come up with one of the numbers on the top, 1 being exceptionally unlikely, 9 being virtually certain, or anything in between. Give you a few more seconds to look at it. And then remember whatever number you come up with, remember that number, and I'll ask you again in a second. Okay. So everyone can open their eyes now. And I'm going to collect some data. Okay. So if you were in the first group, if you went for the number 1, please put your hand up now. We have 1 person. If you went for number 2, please put your... Oh, 3, sorry. Listen. Okay. If you went for number 2, please put your hand up now. Roughly 12. There's observational uncertainty in this, of course. If you went for number 3, you are maybe 10. Was it more? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe 12 at most. Did anyone go for number 4? 1, 2, 3, 4, 5, 6. Anyone for number 5? This is going off the thing now. 1 person for number 5. Did anyone go for number 6? Anyone for number 7? We have a 7. There we go. Anyone 8? Oh, whoa. Anyone 8? Did anyone go for 9? Okay. So in group 2, how many people went for 1? So 1, 2, 3, 4, 5, 6, 7, 8. We'll normalize these by the number of people afterwards. And did anyone go for number 2? I roughly say about, I think 15. I think slightly under this. And then number 3? Maybe similar, maybe 12 or so? Is that more? I'll do 14. I think I didn't see as many as the previous time. Honestly, this is my honest opinion. I haven't worked out which one is yet. Number 4. Okay, we have 4 people there. And anyone go for number 5? We have 2. Anyone for number 6? We have 1. Anyone for number 7? We have 1. Anyone for number 8? Anyone for 9? Okay. So these are the results. Okay, that's interesting. So it kind of supports what I think what I'll show you now is the results from the survey. But if we have a look at the top graph, so we have the minimum to maximum information, and we can see that the maximum actually goes up to around 600 millimeters there. But on the bottom, what we have is the 10th to 90th percentile information. So some of you may not have actually seen that. But we see that this is the 90th percentile, which is about 340 millimeters. And 500 millimeters clearly is quite a way above the 90th percentile, but it's certainly below the maximum. So what we see, and actually this does mirror fairly well, obviously observational uncertainty in these numbers, but it mirrors fairly well what we see in the survey results, and that's this. If you look at these numbers here, so only 3 people went for exceptionally unlikely here, whereas 8 people went for exceptionally unlikely here, and there's a few more people in this side of the room. But what we see is a shift, essentially, in the histogram towards the more unlikely if you show the 10th to 90th percentile information, and then a shift to slightly more likely, perhaps, although it's a bit messy, to slightly more likely if you show the minimum to maximum. And basically the interpretation on this is that if you show the maximum information, then people see that 500 millimeters is below that and say, well, it's obviously happened, so therefore it's a reasonable likelihood. Whereas if you show the 90th, then we don't have the information about whether it's happened or not, and we have to make an assumption about what is the likelihood of surpassing that. But this isn't to say that either way is right or wrong. It's just to say that these choices we make based on exactly the same data can have an impact on how people interpret it. And so a slightly more scientific result is from the actual survey results. And so this is from 235 respondents. 118 saw this and 117 saw this. So it's actually been normalized. But what we can see is that if you have this information, we get a histogram of responses. And so this is the scale here from exceptionally unlikely to virtually certain. They had a sliding bar scale. And they had slightly different numbers as well, so going from 0 to 100. What we see is just by changing the information we show, not the data, we can actually influence the assessment of likelihood of a certain outcome. And so that's one of the results that's from this survey. And I think it's a fairly powerful result in terms of the choices we make about what information we show. And so these are the research questions that lead into this. 2 minutes. Goodness. So these are research questions. How do alternative visualizations of climate change projections affect the usability to understand and interpret the information? And then how, crucially, does the choice of information content affect the user's ability to understand uncertainty and assess climate risks? So that's not just the aesthetics of the visualization, but crucially what information we display as well. We developed a survey, and lots of people responded, so we have 272 complete responses now, which is great. And I'll show you just a few results. And I'm going through this very quickly, but I'd like to discuss this with anyone in detail afterwards. I'd be happy to discuss it. But essentially, we have a very educated audience, and so this is, we approached mailing lists, so the ACDI mailing list, but crucially the Climate Information Platform, which is hosted at CSAG. So they're very much the users of climate information in Africa and predominantly Southern Africa, but also around the world as well. So most people had a PhD or master's, and we span the sectors, so there's a wide span of people answering these questions. And then I'm really going to have to go through these results very quickly, but there's a very simple message I want to illustrate. So we showed a number of different visualizations, and we asked this question: how do you expect the average annual rainfall to change in the future? And again, they had a sliding bar to go from very likely to decrease, very likely to increase. And so these are the types of results we get. So the first thing to say is that people disagree. So this is the histogram of responses, the frequency distribution for the two different samples. And what we see is that and these are just two subtly different visualizations, and we went through, there's all sorts of streams, but I can describe that if you're more interested afterwards. And I'll send anyone who has done the survey will get a breakdown of the results afterwards. But what we see is when we vary the visualization, these histograms, so we're varying the visualizations here, these histograms show, and in fact these are statistically significantly different from, for example, these distributions, which are showing exactly the same data, just slightly different information and visualization. And again, here we get this shift in the distribution. And I've gone through those very quickly, but that's the... And also these were very complicated plots that if you did the survey, you'd have seen them going, what are these? But actually, we get very different responses, and you can actually have the same information in here as the previous graphs. But anyway. And a very interesting result, if I may, and this is the final result I'd like to show, is that confidence is also a function of how we think things are likely to change. So I'll try and describe this without confusing you. But this shows the number of participants. So the bigger the circle, then the more participants answered this. So on this scale, we have the very likely to decrease, the very likely to increase. And this, we said afterwards, how confident are you in your answer? And this is just for this particular one here. And if they're extremely confident, they answer here. And if they're not at all confident, they answer down here. And what we see is this Y-shaped graph, that if people are more willing to say it's very likely to decrease or very likely to increase, they are generally more confident in their answer, which is interesting. And I could talk about that forever, but I won't. We're up. Okay. Then I'll leave you with this quote, because it's nice. Deeper uncertainties do not translate readily into visualizations. In fact, the more attractive a depiction is made, the more people may believe it represents the whole truth rather than being a construction of limited knowledge and judgment. So perhaps the greatest challenge is to make a visualization that is attractive and informative and yet conveys its own contingency and limitations. And that's from David Spiegelhalter on one of the few studies looking at visualizing uncertainty about the future. And I'll leave it there.